is K. Yashwant. I am from Triple Department, first year, second semester. Subject Electrical Circuit Analysis 1. Video presentation. Topic is Superposition Theorem. Statement: Superposition theorem states that in a linear bilateral network containing more than one source, the current flowing through the branch is the algebraic sum of the current flowing through that branch when sources are considered one at a time and replacing other sources by their respective internal resistance. Instead of solving a complex circuit with many sources all at once, consider one source at a time, turn off all other sources, find the contribution from that one source, repeat for all sources, add all results together. How to turn off sources? Voltage source replace with a short circuit, current source replace with a open circuit. Step by step procedure: select one independent source, turn off all other independent sources, solve the circuit, repeat for each source, add all result algebraically. Important conditions: works for only linear circuit, Ohm's law applies, cannot be used directly for power calculation. Power in non-linear, applies to both DC and AC circuits. Example concept: if a circuit has one voltage source, another voltage source, then total current is equals to current due to alone. Why it's useful? Simplifies complex circuits, helps in understanding contribution of each source, useful in circuit design and analysis. The superposition theorem is an important principle in electrical engineering that simplifies the analysis of complex linear circuits containing multiple independent sources. According to this theorem, in any linear network with two or more sources, the voltage across or current through any element is equal to algebraic sum of the voltage or current produced by each independent source acting alone while all other independent sources are deactivated. To apply this, voltage source are replaced by short circuit and current source by open circuit, allowing the circuit to be analyzed step by step for each source separately. This theorem relies on the linearity property of circuits, which closely related to Ohm's law and proportionality between voltage and current. It is applicable to both DC and AC circuits, including those with resistors, inductors, and capacitors, also, as long as the circuit elements behave linearly. However, it does not apply directly to power calculation because power depends on the square of current or voltage, making it an non-linear quantity. Superposition is especially useful for breaking down complicated circuits into simpler parts, making calculations easier and improving understanding of how each source influences that overall behavior of the circuit. It is widely used in circuit analysis, design, fault analysis, and in studying the effect of individual sources in communication and electronic systems. Example: superposition theorem example problem. A circuit consists of two sources, voltage sources, and three resistors. V1 is equals to 10 volts, V2 is equals to 5 volts, R1 is equals to 2 ohms, R2 is equals to 4 ohms, R3 is equals to 6 ohms. Find the current through R3 using the superposition theorem. Step 1. Apply superposition theorem. Consider one source at a time. Replace other voltage source with a short circuit. Find current contribution. Add all currents algebraically. Effect of V1 alone. Deactivate V2 short circuit. R2 and R3 in parallel. R23 is equals to 4 into 6 by 4 plus 6 is equals to 24 by 10 is equals to 2.4 ohms. Total resistance R total is equals to R1 plus R23, 2 plus 2.4 is equals to 4.4 ohms. Total current from V1 is equals to I1 is equals to 10 by 4.4 is equals to 2.27 amperes. Current through R3 is equals to current division rule. R3 is equals to I1 into R2 by R2 plus R3. R3 is equals to 2.27 into 4 by 10 is equals to 0.908 amperes. Step 3. Effect of V2 alone. Deactivate V1 short circuit R1 and R3 in parallel. R13 is equals to 2 into 6 by 2 plus 6 is equals to 12 by 8 is equals to 1.5 amperes. Total resistance R total is equals to R2 plus R13 is equals to 4 plus 1.5 is equals to 5.5 ohms. Total current from V2 I2 is equals to V by R 5 by 1 5.5 is equals to 0.909 amperes. Current through R3 IR3 is equals to I2 into I R1 plus R1 by R1 plus R3 R32 is equals to 0.909 into 2 by 8 is equals to 0.227 amperes. Step 4, find current, final current. Total current through R3 IR3 is equals to IR3 plus IR32 IR3 is equals to 0.908 plus 0.227 is equals to 1.135 amperes. Final answer, current through R3 is equals to 1.135 amperes. Thank you.